Okay, here we are back to chapter 11. We're on page 10. So a couple more examples because there are always different ways that we can solve these. And we are going to use the same strategies we used with linear equations. So here, notice that I got a positive y squared and a negative y squared. So I'm just going to go ahead and add straight down here. And that's going to give me a 3x squared. My y squareds cancel out. 4 plus 8 is 12. I'm already got just 1. Divide both sides by 3 and I get x squared equals 4. Remember, I want every x that makes this true. So x is either positive 2 or negative 2. Okay, now, if you notice, both of these equations have x squareds and y squareds. So I am going to go ahead and start with x equals 2 over here. I'm going to use the first equation. I get 2 squared plus y squared equals 4. 4 plus y squared equals 4. Y squared equals 0, so y equals 0. When x is 2, y is 0. I can plug that into the second one. I get 2 times 2 squared, 2 times 4, which is 8. That is true if y equals 0. So here's one solution. Same thing over here with negative 2. And you notice here we get the same thing. And when we get to graphing conic sections, we will take a look at what type of situations results in 2 intersection points. Okay. So now let's take a look at example 3. We've got something that looks a little different. We're not used to seeing that xy term. So here's what I'm going to do. I got an x squared. Let's go ahead and get rid of that. I'm going to multiply this bottom equation by negative 1. I'll move everything over here to the left, see if I can keep this organized. X squared plus 3xy plus y squared equals 22. I got minus x squared plus xy minus y squared equals negative 6. I get 4xy because my x squared cancels out and my y squared's canceled out. Equals 22 minus 6, 16. Go ahead and divide both sides by 4. Xy equals 16, which doesn't feel fabulous. I'm going to go ahead and just solve for x. I'm going to divide both sides by y. X equals 16 over y. Not pretty, but, and I probably shouldn't have put that in a square. But something that I can probably use to plug into the other one, or one of the equations, and see if I can solve for y. So up here, bottom equation again, I got x squared minus xy plus y squared equals 6. My x is 16 over y squared minus 16 over y times y plus y squared equals 6. So simplifying that, I get 256 over y squared minus, the y's here cancel, 16, plus y squared equals 6, which does not look like a whole lot of fun. So I am going to come in here before I do anything and multiply everything by y squared. Keep in mind I got to multiply everything on both sides. So I get 256 times y squared over y squared minus 16y squared plus y squared times y squared, so y to the fourth, equals 6y squared. These y squareds cancel. I'm going to move my y to the fourth out front. I got minus 16y squared minus 6y, so minus 22y squared plus 256 equals 0. So this we are going to factor and solve. We've got the y to the fourth and the y squared. So we can use a substitution and just call y squared w. Then we could rewrite this as w squared minus 22w plus 256 equals 0. But I will be honest with you, this is not pretty, and we are not going to get numbers that are real numbers. So we're going to stop right here. Because if I'm looking for solutions to a system, I want the places where these intersect. And we're going to focus on real solutions.